channel. Myself Ravi Kumar. In this video, I am discussing about the what are the basic concepts in three-phase circuits. That is, in polyphase circuits, what are the basic definitions you can discuss about that. First of all, in three-phase circuits, how to draw the three-phase voltages or three-phase waveforms. Practically, if we have represent the three-phase voltages or the three-phase waveform in the form of a sinusoidal waveform. The first waveform will be starting from 0. Okay, this is called, you can represent with letter R. Why? Because red. Okay, practically the three-phase lines or the three-phase waveforms you can represent with letters R, Y, B, red, yellow, and blue. Like that, I am writing in three colors. Again, the second waveform will be started here. And the third waveform, okay, these are the three waveforms R, Y, B, red, yellow, blue. Okay, in this way, you can represent the three phase lines in the form of three phase waveforms. Okay, here in three phase circuits, the important point here, the phase difference between any two phases, that is 120 degrees. That is, at each 120 degrees, the second phase line will be started here. Okay, then totally we can call here total difference between, that is 240 degrees between R and B. Between R and Y, the phase angle difference is 120. Again, between Y and B, the phase angle difference is 120. Again, between B and R, the phase angle difference is 120 degrees. That means between every two phases, the phase angle difference is 120 degrees in three phase lines. Okay, in three phases, that all three phases will be displayed, any two phases, in the form of phasor diagram. We can represent here. Suppose this is R, this is Y, this is B. Then between R and Y, the phase angle difference is 120 degrees. Between Y and B, the phase angle difference is 120 degrees. Between B and R, the phase angle difference is 120 degrees. So like that, any two phases are displaced by 120 degrees in three-phase waveform in three phases. It's a very important point. Then between any two, that is between R and B, R and when coming from like clockwise direction, then the total phase angle between R and B nothing but 120 plus 120, 240 degrees. So like that, we can calculate the phase angle difference between the lines also. Okay. Then after knowing about the all three phase waveforms, then we have to write down the equations also. Then before going to equations, the very important definitions is phase sequence. Phase sequence is also very important in three phase lines, especially in practical, that is for three phase motor, induction motor, when connected to three phase lines, in the form of a phase sequence, that is suppose R, Y, B, then it will be running. Whenever the phase sequence will be reverse also, then automatically the running also will be, rotation also will be reversed in case of the three-phase motor. That is, the working running of three-phase motor also will be reversed according to the reverse condition of the phase sequence. That's why in order to apply the perfect phase sequence, then you can obtain the perfect running of the induction motor. Then what is mean by phase sequence? Okay, in about three-phase waveform, what is the first waveform will be appear here? R. Second waveform Y. Third waveform B. That means phase sequence nothing but here the sequential order in which the first peak will be going to the of the waveforms. That means what is the waveform will get first peak value, and what is the waveform will get second peak value, and what is the waveform will get third peak value. That is, you will get the maximum value. So the waveform will reach maximum value in a sequential order. That is called the phase sequence. There are all three phases R, Y, B. Or you can also represent the three phases in the form of A, B, C also. Okay, you can represent in the form of A, B, C or in the form of R, Y, B. Okay, then the phase sequence is nothing but in sequential order. Then all three phases will get the maximum value or reach the peak value. Okay, in this waveform, R by B. First, R will reach the maximum value. That is the peak value of the waveform. This is the peak value of the waveform. Similarly, second Y phase will be reached the second time, and again the B phase will reach the third time in the order R Y B. So that is called the phase sequence. That is, the phase sequence is a sequential order of three phases to reach peak value. Okay, that is called the phase sequence. In practical applications, the phase sequences are very important. Okay. Then here, for example, the phase sequence having two types. That is, the connection of sequence will be in two forms. That is positive sequence, and second one is negative sequence. Okay. What is mean by positive sequence? Okay. For example, here I am writing the phase reference is suppose R phase. Again, the second one is here suppose Y phase, and the third one is suppose B phase. Then the motor or the windings will be running in the clockwise direction. Suppose here, that is, at first position we reach the R phase. Again, after doing with 120 degrees, okay, after 120 degrees, what happened when it will reach in clockwise direction? Then the reference waveform will get Y phase. After 120 degrees is going to the equal. That is, in the next operation, we will get the phase sequence order is nothing but here Vy, again Vr, and again Vb. Like that, the next operation, the reference is Vb, again Vy, again Vr. Like that is the The phase sequence is nothing but R, Y, B. Okay, this phase sequence is called as R, Y, B. If the phase sequence is R, Y, B, then that is called the positive sequence. If any one of the sequence will be reverse here, that is called the negative sequence. That is here, I am taking reference here, VR R phase, and second one here we are taking as VV and VY. Okay. Same again, clockwise direction. Okay. In first step, the reference is VR. In the next step, same. All three phases should be running in clockwise direction. Here VB and here VR and here Vy. That is, it will be rotated again one step in clockwise direction. Then what is sequence here? First is R, second is B, and third is Y. That is, the phase sequence will be disturbed. The order will be disturbed. What I mean that here, the first waveform will this peak is R phase, second B phase, again third Y phase. That is, the sequential order will be disturbed. That is called the negative sequence. Okay, the actual order of the three phases is nothing but R, Y, B. So that is called the positive sequence. Okay, in the form of R, nothing but suppose you can also write down the positive sequence, that is Y, B, R. That is R, Y, B. Again, in the next notation, Y, B, R. In the next notation, B, R, Y. So that is same. That is R, Y, B. R first Y will be applied. What is the next phase? B. What is the next phase? R. If B will be started, what is the next phase? R. Next phase Y. Okay, these are called the positive sequences. Okay, the order is same. Okay, there is no disturbance in the order. RYB, YBR, BRY. Okay, if any two phase will be reversed here, then that is called the negative sequence. That is, suppose RYB sequence is there, it will be disturbed. That is RBY. Then negative sequence. Suppose positive sequence is YBR, then it will the disturbance will be YRB. Then it is a negative sequence. Suppose the positive sequence is BRY, then any two phases, that is BYR, will be changes. Then these are called the positive sequences and these are called the negative sequences. Okay, any two phase will be order will be disturbed there. Okay, then that is called the negative sequence. Okay, this is the complete positive phase sequence about the three phases. Phase sequence will be very important role in case of the running conditions of the induction motor. If any two phases will be reversed, then the motor is running also in reverse direction. Direction will be reverse when the phase sequence will be reverse. Then again to that, in case of phase sequence, what are the equations of the phase waveform? Suppose the reference is VR, in suppose the phase sequence is R, Y, B, then the equation becomes Vm sin omega t, which is reference equation. Similarly, Y here, when with compared to R, between R and Y, what is the phase difference here? 120 degrees. That is sin omega t minus 120 degrees. With reference R, what is the phase difference between R and B? That is 120 plus 120, 240. That is Vm sin omega t minus 240. These are the three phase equations of R phase, Y phase and B phase. In case of negative sequence, what is the first here? Same, VR, that is Vm sin omega t. That is the negative sequence is, suppose for example, RBY. Y and B phases are reversed. Then what about next second is VB? Okay, for B phase between R and B in negative sequence, the phase difference becomes 120 degrees. Similarly, Vy between R and Y, the phase difference becomes 240 sin omega t minus 240 degrees. So these are the basic concepts regarding the phase sequence. Then the second one is here. What is mean by phase voltage? We can represent that is V suffix ph, phase voltage. That is phase voltage nothing but here the voltage across each winding or across each phase, that is called the phase voltage. Then similarly line voltage, okay, that nothing but from the above phasor diagram or the waveform, that is the phase voltages are VR, Vy, Vb or VRR, that is voltage across R phase, voltage across Y phase, voltage across B phase, that is called the phase voltage. Then line nothing but we can consider the line is across two phases, that is called the line. That means line voltage is 2, that is VRY or VYB or VBR. So these are called the line voltages. Okay, that is called line. Line means between the phases, two phases. Only we consider single phase, that is called the phase voltage. In the same way, what is phase current? We can represent with IPH, and suppose line voltage also we can represent with VL. Okay, suffix L means line concept, suffix PH means phase concepts. Okay, the phase current also means same. The current which is flowing through each phase, the current which is passing through each phase or each winding, that is the phase current is IR or IY or IB. So that is called the phase current. Similarly, what is mean by line current? What do you mean by line here? Line consider between the two phases. That's why the current which is passing through any two phases or between RY, that is called line current, or between YB, that is called line current, or between BR, that is called line current. The current which is passing through the two phases, that is called line. Okay, current is called line current. So similarly, after we discuss about the phase voltages and phase voltage, phase current, line voltage and line current. That means in case of three phases all three phases should be considered, that is called the circuit. It's all three phase circuits we can classified into two types, that is called balanced circuit, unbalanced circuit. Okay, balance means equal, unbalanced means unequal. Okay, that means if the three phase circuit consists of all voltages or all currents or all impedances of the phases all are equal, okay, that is called the balanced circuit, either balanced supply or balanced load. The circuit nothing but balanced means you can differentiate the balance supply or load, that is called balanced supply or balanced load. Okay, that means the balance condition means voltages are equal or currents are equal or the impedances, okay, in the three phases are equal. So that is called the balanced circuit. Same unbalanced also we can consider for supply side or load side, that is called unbalanced supply circuit or unbalanced load circuit. That means all voltages, that means unequal, or the currents are unequal, or the impedances are unequal. Impedance means the phase impedance value. Okay, if the all values are not equal, that is called the unbalanced. If all values nothing but voltages, currents, impedances all are equal, that is called the balanced circuit. After that, all three phase windings, nothing but all three phase windings are connected in two forms, that is called are connected in either star connection or delta connection. All three phase windings are should be connected in the form of star or in the form of delta. Then what is mean by star connection? Okay, that is, suppose we can consider this is one winding and this is second winding and this is third winding. Okay, we consider three phase windings. Okay, then here one node point will be formed. So this is called star point. Okay, then this is called R phase. This is called Y phase, and this is called B phase. So this is called star connection. Okay, a node is formed. That's why suppose different currents are passing through the star connection. For example, here what is the phase current IR? That is Im sin omega t. Similarly, Iy, we know, suppose it is balanced, all currents are equal, then sin omega t minus 120 degrees. Okay, all any two phases, the phase difference is 120 degrees. Similarly, Ib equal to Im sin omega t minus 240 degrees. When in star connection, that is balanced star connection, all current values, that is IR plus IY plus IB equal to 0, which is very, very important point. In star connection, the sum of all phase currents will be 0. Why? Because all are equal magnitude. All the magnitude values of currents are equal, but only displaced with angles. That's why the sum of all currents will be 0. In the similar manner, same, the second connection is delta connection. The second one is the three-phase connection, the three-phase winding or should be connected in the form of delta. Delta means a closed loop. That is, this is one phase and this is second phase and this is third phase. The three phases are connected like this. Then here between any two joining two phases, then a node point will be obtained here. This is one and this is second and this is third, which is suppose R, Y, B. Okay, then it is a closed loop. Okay, delta means it forms a closed loop. Apply KVL for closed loop. What happened? All in closed loop, all voltages will be 0. That's why in delta connection, suppose we know the voltage value, that is voltage value of R phase, nothing but E equal to Em sin omega t. Similarly, Ey equal to Em. We know the two windings or two phases are displaced by 120 degrees. Similarly, Eb equal to Em sin omega t minus 240 degrees. Then according to KVL, the total voltage, that is ER plus EY plus EB equal to 0. The total voltage in a closed loop is 0. This is the condition for in case of delta connection. In case of star connection, the sum of the all three phase currents will be 0. Okay, these are the basic concepts regarding three phase circuits here. The very important concept in three phase circuit is nothing but phase sequence. If the phase sequence is reverse, that means suppose for example this is induction motor, then it has three winding connection, that is I am showing with the colors. The first is R, second one is white, yellow, and third one is B. Then we have three phases R, Y, B here also. That means red, yellow, and blue. Then all three are joined, that is supply side. So for example, one each other. Then suppose the motor will be running, the motor will be running in clockwise direction. In clockwise direction. Or If any, the connection of or the same induction motor and the same R phase, Y phase and B phase. Suppose RYB, here also B, R and Y. Then the connections, for example, will reverse. B is connected together and R is Y connected to R and R connected to Y here. For example, that is any two phase sequence will be reverse, that is changes. Then the induction motor first will be clockwise direction. When the phase sequence will be reverse each other, then the induction motor will be running in anti-clockwise direction. Okay, so this is the very in case of running induction motor or any machine, the phase sequence concept is very most important. And also the balance condition means all values are equal, either voltages, currents, impedances. Unbalanced means the value should be reverse, different. That is voltage, all three phases are different, all three currents also different, all three phase impedance also different. That is called unbalanced system. Okay. Please subscribe our channel and share to your friends.